So as far as the basics of dams are concerned, dam is nothing but a barrier that stores the water at two levels. One is at the upstream, one is at the downstream. So the primary purpose of dam is to store the water whenever available in plenty for use during the scarcity. Means that water can also be used for the irrigation, can also be used for the drinking purpose, can also be, it is used as a water storage, and that can be converted into the water supply system. So these dams are built across the water flows, that is the rivers, basically. So the excess of water is released to the river and useful water is transferred into the canals. So canal conveys the water. Canals are the main carrier for the irrigation purpose. They are the carriers of water. So that's why dams are useful. But the construction of dam is not that much easy. The site selection of dam is not that much easy. It depends upon various factors. And if your site selection is not proper, then your dam may undergo the failure. So that's why this failure results into the severe loss of life and property. And you all know that it takes many years to build a dam. So that's why before its construction and before its planning, the proper site selection is required. So what are the various components of dam? So this dam is having the main body of dam, that is the wall that is going to be constructed to restrict the flow of water, foundation of dam, as well as the abutment of dam, top road for the communication, gates to release the water, and lifting devices, then spillway or sluice gate to release the water into the downstream side, canal to convey the water, reservoir to store the water, main river course, that is the your riverway, stilling basin for the collection of the various sediments and gravels, drainage gallery for the drainage purpose. Then again, inspection galleries is also there. Then various devices are also set in that inspection gallery. So these are the things. What is the lifting devices? Lifting devices means the devices which are required to open the gates, to lift the gates. The gates are very heavy, and that's why these strong devices are required. Now, in this diagram, in this image, in this graphics, you can see upstream side and downstream side. So upstream side is a reservoir side, is a storage side. Now this dam here in a red color, you can see in a trapezoidal shape. So the trapezoidal shape is maintained because of to prevent the horizontal thrust, horizontal force created by the huge amount of volume of water. To resist that force, to resist that moment or lifting moment which is causing on this wall of dam, this type of shape is preferred. So this is the basically a trapezoidal shape, as you can see here. Okay. Then this is a main dam body. This dam body will rest over the foundation. The concrete foundation is required. Then on downstream side, the foundation extends, the foundation compacted soil will be there. Then on downstream side, the stilling basin will be there to collect the silts, gravels, which flows along the water. Then upside to that, you are having the sluice gate. Now this sluice gate is what you can say a spillway. It is below to this spillway, which also conveys the water. A tunnel is created along the dam to pass the water from upstream to downstream side, as you can see. Then drainage gallery is there. Along with that, the inspection gallery is also there, which measures the seepage and drainage through this dam. Now, there is a spillway, and for that spillway, the gate is there, which is nothing but the main gates for this dam. And for this gate, you are having the lifting devices to lift that gate. Now, what is the use of this sluice gate or this tunnel? This tunnel is used to remove the saturated silts in the upstream side. This tunnel is used. When this sluice gate get opened, this type of saturated silt material gets flown over the downstream side. Now, there are various types of spillways. As you can see, this is a parabolic shape. This spillway is having the parabolic shape to reduce the effect of water hammer on the downstream side. So along this parabolic curve, the water is conveyed to the downstream side. So this is the what you can say basic components of this dam. Now in actual picture, you can see this is a spillway. This is a straight spillway. It is not having here the parabolic shape. So this is a small dam. Upstream and downstream sides are shown here. Now this is a what you can say a top view diagram. Now in this diagram, you can see on both sides the abutment is there. Such like the abutment is present on a bridge. In the same manner, the abutment is there for your dam wall also. This abutment is the supports on the both ends for your dam wall. Now, on in top view also, you can see the downstream side is having a trapezoidal shape. That is the extended shape to release the water flow. So this is a main river course along which you have constructed this wall, that is the dam, to store the volume of water. So now on both sides in trapezoidal shape on downstream side, you are having the canals. That is the left bank canal for the river and right bank canal for the river on downstream side. Now why these canals are used? These canals are also used as a carriage of water as well as an emergency purpose when the water level rises above the HFL, that is high flood level. These canals will be useful to release the huge amount of water. Now this type of dam, we already discussed that this type of dam is which dam? It is a arch type of dam. It resists the force of water by the arch action. So this is the arch type of dam. It is having the vertical wall. So in this type of dam, you may not have the trapezoidal shape. You may have the, you may convert it to the buttress dam to give the extra support, but basically it is just a arch type of curve, as you can see in this image. So whenever construction or planning of dam is there, then the preliminary investigation is required. So the investigations are made to ascertain the merits and demerits. Now, if you select any site, then what are the advantage for site for that particular site and what are the disadvantage for that particular site that are noted. After that, this kind of investigation is necessary so that detailed investigations are made, are much more expensive, extensive, and laborious should be made only if the site is approved. Means why this preliminary investigation is necessary? It is before the detailed investigation, because your detailed investigation requires the huge amount of cost, time, and as well as the manpower, right? Because the dam site is spreaded across the various square kilometers. So a huge amount of land is to be surveyed, right? Various readings are to be taken, various levelings readings are taken. How much will be the catchment area, how much amount of water will be stored, or how much amount of will be HFL, and for that HFL, how much the water will acquire the flood area. So all this analysis, all these studies are to be required before the construction of dam, and that's why this preliminary investigation is required to avoid the repetition of this type of detailed investigation. So preliminary investigation gives us the proper site for the dam. So the dam site selection, the first step is preliminary investigation. Now, various factors are considered in preliminary investigation, such as the groundwater conditions, then exterior topography. All these things are considered. So the site selection criteria, what are the criteria, necessary criteria? The rock should be sound and resistant to the expected static and dynamic forces, including the earthquakes. So, as you know, in case of the Koyna Dam, the earthquakes are always there. So, the basic condition is for the stability of the dam. The rock should be sound, means it should be firm. The strength of that rock should be highest. The compressive strength should be highest because it has to resist the huge amount of pressure. So it has to bear the static and dynamic forces, means stable forces and varying forces also. Which are the dynamic forces? Force due to the earthquake, that is the seismic force, is the dynamic force. So it has to resist that. So ultimately your rock should have the higher strength. Then the valley slope should be stable when the reservoir is full. Now, what is the valley slope? Normally, you construct the dam selecting a valley site. If a natural valley site you will get, then the water will get automatically stored or automatically it will acquire the reservoir shape. So that's why when the mountains are there alongside the river, then for such location, for such site, the valley is preferred because the valley will also give you one more advantage, that is the length of wall for the valley is less, because whenever the valley will be there, the V shape will be there, and for that V shape your cost of construction of dam wall will get saved. So this is the advantage of the valley side. So this requirement also applies to the rock abutments, because your valley will act as an abutment. On both sides, it will provide the support to your dam wall. Then the third point is the foundation of the dam should be safe from the sliding. So the foundation should not slide. Then now the question arises that why the foundation will slide? As there is huge amount of horizontal force exerted on the dam wall, it is going to be exerted on dam wall. Then in such condition, what will happen? Your dam wall is resting over the foundation. Both are connected to each other, right? So it may happen that your dam foundation may skid or may slide in the forward direction. So this should be avoided, especially in the case of gravity dam, where your whole water pressure is resisted by the gravity action. That is the self weight of the dam wall. Now the next various points are such that the foundation and reservoir should be watertight, means there should not be the seepage. Then rock at the site should be resistant to the solution erosion, decomposition, and detriment effects of wetting and drying, freezing and thawing. Now the rock, the various factors affecting on the rock is the temperature action. The contraction and expansion will take place because of the temperature action. In summer, the size of rock will swell. In winter, it will get contracted. So the rock should be such that there should be, or there will be, the minimum effect of this temperature stresses. Then for the rock, the erosion also takes place. That leads to the decomposition of the large rocks, right? So erosion means the extradition of the rocks, and because of this the rock will get cracks, rock will may get splitted into the pieces. So the sediments get formed because of the large rocks. So that thing should not happen. Then drying, freezing, whenever there is a in cold condition, whenever there is a snowfall, at that time the temperature goes below 0 degrees Celsius. So in such condition, because of the extensive contraction, expansion, and temperature stresses, the erosion may take place. So your rock should be resistant to all these conditions. In the reservoir drainage area, including rocks and overburden, should be resistant to erosion and therefore not likely to contribute such heavy silt loads to the reservoir. Now, the reservoir drainage area, including rocks and overburden, should be resistant to erosion. Now, this overall area should be resistant to the erosion, because erosion, there is a possibility always that the erosion will take place because of the huge amount of weight is exerted, as well as the water flow is there. So that thing should be minimized. We cannot say that all these things should be avoided, because practically it may not be possible to avoid all these things, but that thing should be minimized. The geology and topographic conditions should permit favorably for the location of spillways and divergent tunnel, powerhouse, and outlet conduits. Now, conduits is nothing but the, what you can say, the penstocks or the carriageway for the water. Now, geological condition, topographical condition, that is the exterior conditions, should permit favorably for the location of spillways. Now, spillways carries the water to the downstream side. Divergent tunnel. Divergent tunnel is used to divert the flow of water into the canals and powerhouse. So your topographic condition should be favorable to this flow of water which takes place through the tunnel, through the spillways, through over the powerhouse, over the outlet conduits, over the canals. So this topographic condition should be favorable. Means what? The various alignments should be checked. That is the main intention. The location of construction materials, particularly concrete aggregates, should be within an economically justified distances. Now you require the various construction material, so that material should be available nearby. That is the thing. So this is the image which shows the construction of dam, undergoing construction of dam. Now, in such way, various concrete dams are constructed. Again, this is a, what you can say, arch type of dam. So now there are various functions which serves the dam. Power generation is one of the purpose, to stabilize the water flow for the irrigation. Flood prevention, whenever there are the floods. Now there are floods on the Koyna river, then Krishna river in the western Maharashtra. So the dam prevents the floods also, right? Because at up to certain level, the dam stores the huge amount of water. It also prevents the floods. Land reclamation, then water diversion. Water diversion takes place because of the dam, because whatever the water flowing through the river, you can divert it to the canal. So that is nothing but the water diversion. So in previous lecture also we have seen the types of dams based on the purpose. Now, what are the various purposes, such as the storage, then detention, diversion, coffer dam, and debris dam? These are the basic 5 types based on the purpose. So first one is storage dam. Storage dam, the main purpose is to store the water. Detention dam, it is primarily constructed temporarily detain the amount of water or part of flood water. So detention is to detain the flow of water for certain duration, for temporarily purpose. This type of detention dam is constructed. Whenever there is a large area to be constructed and the water flow is there, then to prevent that water flow, the detention dams can be constructed. Now diversion dam, as we have discussed, to divert the flow of water to canals for irrigation purpose, these diversion dams are used. Then coffer dam, it is also the temporary dam, but it is made up of the combining various segments. So that's why it is called as the coffer dam. It is made up of the various materials such as the sheets, and it is to be constructed where the large amount of area is under construction and temporarily to prevent the flow of water. So in this case, it behaves like a diversion dam. When you divert the same flow of water, then the function is also to divert the flow of water. So coffer dam basic function is, it is a temporary dam, it is a small dam, it resists the flow of water, that is the main flow of water, that is the mainstream flow. Then debris dam, it catches the various silts, then gravels, then various sediments. So to collect all these things, a small dam is made, that is the debris dam. So the main function of this debris dam is to collect the silt, segment, gravels, which flows with the water. So this type of things get saturated in debris dam, and after that, that dam is cleaned and that material is collected. So this is the main purpose of this debris dam. Now, based on the hydraulic design, you can classify it as the overflow dam or overfall dam and non-overflow dam. Overflow dam means the water get overflowed over the crest. So that is the overflow dam. It is basically designed to overflow the flow of water. The non-overflow dam. So the water is not allowed to overflow over the crest, over the wall of dam. So that is nothing but your overflow dam. Then based on the classification, based on the material of construction, so you may classify it in the basic two types, that is the rigid dam and non-rigid dam. So rigid dam is made up of the stone, masonry, then concrete, steel or timber, that is the rigid material is used. While as in non-rigid dams, you use the gravel, sand, silt, clay. That is nothing but your non-rigid material. That is the material is in the pieces. Whereas in rigid dam, the material is in segments. Okay. So the various materials are used, such as this type of gravel, sand, silt, clay for the earthen dam. For tailings dam, the waste and refuse obtained from the mines. So when the waste material is there, when the huge amount of excavation is there, that excavated material is used in the dams. That dams are called as the tailings dam. Then rockfill dam, the rock material supporting a watertight material on the upstream face. So the big rocks are used. So that type of dam is the your rock fill dam. Earthen dams are provided with a stone masonry or concrete overflow spillway section. Such dams are called as composite dams. Now, in earthen dams, if the stone masonry is also used and concrete masonry is also used, means concrete structure is also used for the spillway section and stone masonry is used overall the dam. So that is the composite materials we have used, and that's why these type of dams are composite dams. So in some cases, part of the length of the dam is constructed as earth dam and rest as masonry dam. So such dams are called as the masonry cum earthen dams. Again, it is a type of composite dams. Now, based on the structural behavior, how you can classify it? Structural behavior. That is your structural concepts, such as the gravity is used to resist the flow of water in gravity dam. Then arch action is used to resist the flow of water, to resist the force exerted by the water. So that is the arch dam. Then the force is resisted by the buttresses. The force is equally divided into the various buttresses. In case of the buttress dam that we have seen previously, the same force is resisted with the help of the embankment in case of the embankment dam. So these are the classification based on the structural behavior. Now, what is the gravity dam? So it is a masonry or concrete dam which resists the forces acting on it by its own weight. So it is triangular in shape. Triangular means the trapezoidal in shape, basically. So gravity dam resists the forces because of its own weight. That is the gravity dam. So straight gravity dam that is straight in the plan. So curved gravity dams, that is the again one more subtype, that is the arch gravity dam. Means the dam resists the force by the gravity action, but it is in curve shape. So that's why it is called as the arch gravity dam. So it raises the forces acting on it by combined gravity action, by its own weight and arch action. So the combined action is there. So that's why it is called as the arch gravity dam. Then solid gravity dam, its body consists of a solid mass of masonry or concrete. Then hollow gravity dam, it has a hollow spaces within it. Most gravity dams are straight solid gravity dams. So in most of the cases, this type is there. Then concrete gravity dams, weight holds dam in place. Lots of concrete, expensive materials are used because concrete is expensive, right? Rock you will get by the excavation, excavator materials you will get, but concrete you have to purchase it, right? So that's why this type of dams are expensive. These dams are heavy because the density of concrete is also there. So these dams are heavy and massive. So wall-like structures of concrete in which the whole weight acts vertically downwards. So the density of this weight density of this concrete varies from 24 kilonewton per meter cube to 25 kilonewton per meter cube. Okay. So this type of gravity action is also there. As the entire load is transmitted on the small area of foundation, such dams are constructed where rocks are competent and stable. So as your foundation should be firm, foundation should be strong. So that's why the main thing is that your foundation should be strong. Your foundation should be stiff. That is the basic thing. And that is rested on the, that should be rested on the firm rock, right? So the Bhakra Dam is across the river Satluj in the Himachal Pradesh, that is the Bhakra Nangal Dam. The construction of this project was started in 1948 and completed in 1963. Now, this dam is one of the major dam from the India. So the length at the top is 518 meter, that is near about half kilometer, and various other specifications are also given. So Bhakra Dam is the highest concrete gravity dam in Asia and second highest in the world. So now you as a student should remember this thing. This thing may be asked in a competitive exams. Now the second one is the arch dam. So it's a curved masonry concrete dam, convex upstream and concave downstream, as discussed earlier. The only arch dam in India is the Udupki Dam, having the double curvature in plan. It is a concrete arch dam. So Udupki Dam is the only arch dam in India. So what is the specification of this dam, or what is the feature of this dam, is that the arch shape gives the strength and arch action resists the force of water. Less material is required in arch dam. It can be constructed at the narrow sites in V-shaped valley. In V-shaped valley also you can see such type of dams. Mostly these type of dams are in the foreign countries. So the main requirement is it needs the strong abutment, because all your force is exerted on the abutments on both sides. So in this image you can see this arch dam, right? So all our force is get exerted on the both abutments. So this type of dams are concrete or masonry, which are in curve shape. The shape helps to transmit the major amount of water. Now arch dams are built across the narrow and deep river portion, but now in recent year they have been considered even for little wider valleys also. So in wider valleys also this type of construction may be possible. So in this image again you can see one of the arch dam. So in this image you can see that it is constructed over the valley. Now in this image you can clearly see the various rocks are there on the both abutments.